framework, you need to know age is the predictor. Happiness is the outcome. So which means, well, you assume that if people older or people younger, they will be happier. Okay, so let's look at the. Sometimes you will see the correlation here, but sometimes you won't see the correlation here. Well, let's just check that. Okay, so it's negative, so which means this causal relationship, okay, this is a negative causal relationship. It means if you are older, you are less happier. You are not that happy as young people, because you know you are going to die. However, we have another moderator, gender. Age, this is a continuous variable, so you cannot divide them into young versus high condition. Okay, as I said, this is a continuous variable. But gender, okay, this one is the general linear model for process dichotomous variable or continuous variable. They are all the same. So let me demonstrate that for you. Okay. And if you recall that, okay, after you install that, you will see here, it's called process version 4. Okay, because after every time if we restart the computer, okay, this lab, all the computers in this lab already set some programs. So once you restart, all the something will be clean. Okay, so that's the reason. I already installed the version 4. Okay, but after I restart, it's clean. Okay, but it's fine. I just use process 4, a process version 3.4. Okay, our predictor X, that is age. Our outcome is happiness. You could see here moderator, covariate, mediator, covariate, moderator. Okay, so that is the moderator gender. Hold on a second. Model of number. So there are so many models. Which one you should select? Type Google SPSS template process, and you will see the first one: Introduction to Mediation, Moderation, and Conditional Analysis. Something else, and then you'll see this one. Okay, 15% off. Okay, now if you buy the book, you will get 50% off. Okay, this is the author. Okay, recommended by Shady Brown. Okay, department. Okay, USC. Okay, U of Texas. Okay, Virginia. Okay. This is the book. Okay, but we don't need this one. We need this one. See, model 1. The same, right? Model 1. So we should select model 1. And then you will say, Professor, model 1, okay. Model 1, we have X, we have Y. So now please tell me what is this one? X times, we have X, we have Y, we have a moderator. So predictor will be X, moderator, and X times moderator. What is that? We call that interaction, right? So that's the reason I said ANOVA is a special case in regression, and regression is also a special case in general linear model. Okay. So this is the interaction. So you could use regression to test the interaction effect. And then let's keep moving. Model 2. You could add two moderators. Model 3. This effect is moderated by this moderator 1. And this effect is also moderated by moderator 2. So I remember this is called what? No. This is a traditional three-way interaction. See, three-way interaction, x times w times, times n times w. Okay, so this is a three-way interaction. And then we have a three two-way interaction, 1, 2, and 3. And then we have a three manifest, 1, 2, and 3. So this model is used to test the three-way interaction. And then today we will talk about model 1 and model 4. Model 4 is a mediation. Okay, I will talk about this later. And then you may say, well, professor, say there are so many models. So so any model that you could come up with, I believe that most of the models are included in this manual. See? Right. But if you are a master student, don't worry about that. I don't think your advisor will ask you to run this complicated model. And we are so thankful for this author because he already provided all the program, the code, the syntax for the model. So let's just select model 1. Model 1. And then confidence interval, okay, 95%. Numbers of bootstrapped samples because it uses computer to run the simulation. Okay, so it will automatically generate some numbers and check which number is the best one. Alright, so that will do that again. Okay, just like a loop. Alright, so if you select this one, it means the computer will run 5,000 times. Alright, but it takes too much time. So let's just check, select the 1,000 times and see if we will get the answer. See, complicated code. So now please tell me what is predictor age. So what is outcome, happiness. Okay. The default is only allow like 7 characters. Okay. Happy name. 1, 2, 3, 4, 5, 6, 7, or 8. Okay. Sample size of moderator, gender. Sample size 163. Okay, model summary, significant. Constants, C, it's a regression, right? So now, please tell me constants. I said a constant is always a significant. Okay. The first one, main effect of age, significant or not?
No.
Significant or not?
Not.
Significant or not? Smaller than 0.05 or greater than 0.05?
Greater.
P-value smaller than 0.05 or greater than 0.05? Greater than 0.05, right? So it's not significant. Okay, you could also identify that from lower bound versus upper bound. See, negative, positive. If you check this, the confidence interval, and then this range cover the 0, okay, which means this is not significant. Let me say that again. If you see the range, okay, it's here. So it means it's significant. However, if you find a number cover the 0, which means the test is not significant. Not. Okay. So keep this in your mind. Not. So let's check this one. P-value is 0.35, not significant. Okay, let's check the confidence interval. Cover the 0. Okay, check, not significant. Gender. P-value 0.0001, significant. Check confidence interval from 0.05 to 0.19. cover the 0 or not. Not. So which means it's significant. Check the interaction. P-value 0.0005, significance. Check the confidence interval. Negative 0.07 to negative 0.02. So it's significant. Okay, and then we check this one. See, test of a higher order unconditional interaction. This is the interaction term. Okay, p-value is 0.0005. 0.0005. Okay, so which means this interaction is significant. This moderation effect is significant. Okay, and then we could check this one. Okay. 1 and 0 check. Okay, let's assume that 0 is one over 0. Wait a minute. 1 and 0. Okay, let's say 1 is male, 0 is female. 1 is male, 0 is female. So for female, there is no difference. Okay, there is no difference. For female, there is no difference, which means for female, okay, age cannot predict happiness. However, for male, it's significant. Okay. Significance. So when age predict happiness, this effect will become weaker. Okay. Sorry, let me say that again. For female, age can predict happiness, but the effect won't change. But for male, this effect will become weaker. Why? Because this effect is negative. This coefficient is negative. Okay, let me prove that to you. Okay, let's check the original one. Happiness and age and happiness. The original correlation coefficient is negative 0.154. Ideally, if we separate that, okay, by gender, the correlation coefficient should change. Okay, so let's check that. Because this is our moderator and this is the dichotomous variable, so we could do that. Okay, see, if we put the whole sample, the correlation coefficient is negative 0.15. 0 is female. So now, please tell me what is the correlation coefficient? 0.113. However, significant or not? Not. So what does this mean? For female, age cannot predict happiness, right? Let's check male. What is the correlation coefficient? 0.383. P-value significant, which means for female, age can significantly negatively predict happiness. So see, this effect is even stronger than the original number. Do you know what I mean? So this number is mixed by male and female. So if you get the conclusion, you say, let me tell you the conclusion. Age can predict happiness. Other people may say, no, you are wrong. This conclusion is only acceptable for males, not for females. You check this, it's very obvious, right? This conclusion is only acceptable for males, not for females. So that's the reason we call this gender as a moderator. It will moderate the effect of age on happiness. Is that clear? Okay, this is a dichotomous, so we could do this. Let me test another one. Let me try this one. Age, okay, work hour, work performance. So we could assume that if we work, if we work long, if we work hour, let's assume that 5 hours, 7 hours, 10 hours, number of hours, if that is greater, ideally you should have a better performance. Ideally. Work hour, work performance. Oh, I see. It's a positive correlation, right? But now we add one more variable that is called age. That's called a moderator. So if you ask me, I will say, well, it's probably acceptable for young people. Okay, if they work, spend more time to work, okay, they have work better performance. But it may not acceptable for old people. Why? They are too old. Okay, if you ask them to work longer, work with more hours, they will tell you, I feel sleepy. I just want to go home. It won't improve their work performance. Okay, now it's just my hypothesis. So let's test this. Pay attention on this. Continuous variable, continuous variable, continuous variable. Let's check that. The three variables are all continuous variable. So it's impossible to test this with ANOVA. I see 1 to 5, 1 to 7, okay, from 18 to 53. Okay. So let's try this. Our X, work hour, our Y, work performance, our moderate age. Okay. Okay, see. So another summary, okay, significant. Work hour, not significant. Age, significant. Interaction, significant. So let's look at this interaction if it's significant. Okay, F value, okay. Here, it's conditional effect of the focal predictor at the value of the moderator. Why? Because age is a continuous variable. So you cannot divide that, okay? But the computer will generate the number by you. So apparently, according to this one, you could see that for young people, it's not significant. For old people, okay, it's significant. Okay, it's significant. So which means the age can moderate the effect of work hour on work performance. So I remember there is a function that we could draw the figure. Action. Generates code for visualizing interactions. Continue. Okay, I select this time 50,000 times. Okay, it will take a long time to wait. Okay, now I know. Okay. So you could get this one. Okay, the same results, significant interaction. Okay, and then you could do like this. Copy, file, new syntax, text. What is that? Where is my one? Oh, here. Okay, see. And then I could select this one. See, the computer will drag this one for you. Okay, so you could see that this green line 41 is here. Okay, you could see ideally the slope is significant. However, if you look at this line and this line, this is not significant because the slope is very close to zero. 如果你看斜率的话，很接近零。Okay. So this is the way that we could draw a graph in SPSS. And of course, you say, Professor, well, I remember last week you said we could make it in a three-dimension graph. Of course, we could do that. Okay, our Y is local performance. Our X is our age. Okay, so you could see it looks like this one. Work hour, high work hour, all the people they have the best work performance. So the oldest one, work hour more is here. Alright, so see the pattern should look like this. I understand that it's very hard to like visualize the 3D dimension graph, okay? So that's the reason I use this way to demonstrate the graph, okay? So this is a very traditional interaction, okay, with very continuous variables. Okay, so we call that moderation, okay, moderation effect, which means this moderator may make this effect stronger or make this effect weaker. Okay. With this case, because this is a dichotomous variable, so I could divide that into male versus female and demonstrate the correlation for you. But for this one, we can't because age is a continuous variable. Age is a continuous variable, so we cannot divided them into two conditions. We could just use the function to make the graph. Okay, so that is moderation effect. Moderation effect. So keep this in your mind. The basic causal relationship is age can predict happiness. In your thesis, in your master thesis, if you just tell other people age can predict happiness, nothing new. Why? Because it's common sense. But if you tell other people, well, it depends on the situation. Situation means, well, for some people, you could see this relationship, but for other people, you cannot see this relationship. Or you could change this one, like a location. In Taiwan, in US, in Europe, okay, in different places, this relationship may change. Or in different like industrial area, okay, electronic area or industrial area or medical area, this relationship may change. So when we talk about the moderation, we actually talk about on what conditions this causal relationship will change. Will change. Is that clear? Okay. So let me say that again. Moderation analysis is more advanced. So I won't test this in you. I won't test this in our final. So don't worry about that. You need to know how to do this. If your advisor asks you to do quantitative analysis, you need to know how to do this. So this is called moderation analysis. So let's look at the next one, mediation analysis. mediation analysis. Okay, mediation analysis. Mediation analysis is different from moderation analysis. Moderation analysis is looking for moderator, which means we want to know the relationship on which condition, on which situation, or on what kind of circumstances the relationship will change. With the case, we use moderation analysis, but the mediation is totally different. Mediation is used for examine a process. Let me say that again. Mediation is used for examine the process. Process means you assume that X will influence Y. X will influence Y. However, this is not the whole picture. The reality is X influence mediator first, and then the mediator will influence Y. Okay, let me say that again. X influences mediator first, and then mediator influences Y. So the very long time ago, the traditional way is to test if X can predict Y, and then X predict mediator, and then mediator predict Y, and then partial out the effect. Okay, if you Google that, you'll find a very traditional old way. David Caney, okay, but he passed away. Okay, he is in connecting. He's very famous, connecting, right? Okay. I remember after he passed away, my colleague took his office, took his office. 因为我记得他过世了，我如果没记错的话，应该过世了。Mediation. Okay, so David Caney is the first one. Okay, proposed the idea about the mediation. Okay, so you can see this X to Y, X to Y, and then X to mediation to Y. So 4 steps. Okay, the first one show the causal variable is correlated with the outcome. Show the causal variable is correlated with the mediator. Show the mediator affect the outcome, and then to establish the mediator completely mediate the XY relationship. Okay, so this is a very traditional way to do this. But now we don't do this anymore because with this method, okay, there are some this is not the perfect method. Okay, so now if we want to do the mediation, I believe that all professors will recommend you to use the method proposed by David Caney. Okay. We usually now use the more advanced analysis. Okay, so that is model 4. Model 4. Okay, so X mediator mediator influence Y. So what does this mean? It means if you increase X, this is the positive relationship. If you increase X, the Y will increase, right? Let me say that again. If this relationship is positive, you increase X, the Y will increase. Okay? And then if this is a negative relationship, it means if you increase X, the mediator will decrease. If the mediator decrease because of this relationship is negative, so the Y will increase. So the basic idea is the process. If you increase X, and then the mediator will increase or decrease. If the mediator increases or decreases, the outcome variable y will increase or decrease. Okay. So in terms of to check that, we also need to check if the three variables they are related to each other. So let's look at the same example. Work hours, health, work performance. So ideally, okay, listen to me. Ideally, you have x, you have a mediator, you have an outcome. The three variables should correlate to each other. Okay, so which means x, uh, x should correlate with y, x should correlate with mediator, the mediator should correlate with y. Okay. However, in some circumstances, you cannot see the perfect correlation matrix here, but you can still see mediation effect. Okay, so with that, you need to use the process macro to check that. So that's a check that. This is the model. We know X is work hours. Mediator is health. Outcome is work performance. Mediator, okay, this is not a model. Now this one. Model 2. Now this one. Model 3. Now this one. Oh, model for this one. C, X, mediator, Y, X, mediator, Y. So the way how you graph the pattern, the process, or the models, okay, somehow indicates you are working on mediation or moderation. OK， 你怎么样画这个研究架构图，就已经在告诉别人你在做什么研究。If you want to conduct a moderation analysis, you need to make a graph like this. If you want to conduct a mediation analysis, you need to make a graph like this. So your graph is telling our people what kinds of analysis you are going to conduct. Okay, based on this, I could tell I need to select model 4. Model 4. Work hour, work performance, and health. Model 4, now model 1. Okay, let's see if you select model 1, what will happen. Okay, this is predictor is work hour. Outcome is work performance. Mediator is health. Okay, and then you select the model 1. Model 1 is moderation. Okay, let's assume that you select the wrong model. Let's see what will happen. See, error message. You have specified an M mediator variable in the model that doesn't use it. In this release of the process, moderators are W and Z in model 1, 2, and 3. So apparently, if you select the wrong model number, the outcome will tell you you are doing this in the wrong way. So we have to change that. We need to select the model 4. Okay, model 4. X is work hour, Y is work performance, mediator health. Okay, model summary significance. Okay, model 1 work hour. Okay, predict work performance significance. Okay, put this. Okay, a work hour predict work outcome variable significance. Health predict this one significance. But the point is here. This is called direct effect. This is called indirect effect. So what is direct effect? What is indirect effect? That is this is a work hour. This is work performance.
28, no? All proportion.
This is
Okay.
health. Okay, so let's look at this. We have direct effect. Direct effect is here, 0.3064. This is direct effect. And then we have indirect effect. Okay, look at this one. So now please tell me indirect effect. We don't have the p-value, so we can only adjust that. We can only identify that by the confidence interval. So now please tell me the range. Cover 0 or not? Not, right? So if the range doesn't cover the number 0, significant or not? Significant. Okay, so now we have the number 0.0442. This one is significant. This one is significant. Okay, so let me try that. Okay, here. So if you have this, okay. So let me try this again. I run through traditional regression. With this one, the first one is work hour. The second one is health. So this is the number. Okay, I can use this one or this one. Okay, I just take the standardized number. The number should be very close, but won't be totally the same. Okay. And then health is the predictor. Okay, so let me try this. The indirect effect is 0.0442. Let me see if I can get the number. See, please tell me the number. Point what? 042. What is the indirect effect? Hello? What is the indirect effect? 0.0442. 0.042. Okay. Very close. Okay, if we just take the two decimal, okay, that should be 0.04. 0.04. See, they are almost the same. So here we know the this one. I forget the coefficient. The original one work hour. This one is 0.268. Right, 0.268. Okay, so this is the direct effect. This is the indirect effect, right? And then C, please tell me the number. X is work hour, Y is work performance here, right? Okay, now let me do the math again. Point 268 plus direct effect, indirect effect, 0.042, sorry, 0.0442, 0.0442. Okay, so this is 0.3122. 0.3122. 0.3122. If we take the two decimal, this is 0.31. 0.3122. So you could still get the same number by your own calculation. Okay, but since we have the macro, okay, we have this one, so we don't need to do this by hand. We could just rely on this mediation analysis. Okay, so again, look at this coefficient. Okay, coefficient positive, positive, positive. So how do we interpret this result? If you just ignore this mediator, you may interpret work hour can positively predict work performance. Okay, but it's not the whole picture. The real picture is if you have more work hour, okay, you may increase your health status. Okay, and then if you have a better health status, you will have better work performance. You will have better performance. Okay, so this is the path we use mediation analysis to interpret the whole picture. So X and Y, this is not the whole picture. The whole picture is this one actually influenced the mediator, and the mediator influenced the outcome. Okay, and this is not directly influence this one. Okay, so this is called mediation analysis. So when we talk about the process, we use mediation analysis. But if we really want to know, well, this causal relationship is this relationship, if this relationship exists in this condition versus another condition, or in this circumstance versus another one, or for this type of people versus another type of people, we use moderation analysis. Okay, moderation analysis is to look at the effect happens on some like circumstances. But mediation analysis is used to examine the process. Okay. Is that clear? Okay, so in terms of moderation and mediation analysis, I finished. And if you are not that familiar with this two part, it's fine because it won't be tested in our final. Okay, I introduced this because my student is in this class and they will use that in their thesis. So that's the reason I introduced this too. Okay, but I'm not so sure for undergraduate students if your advisor will ask you to do this advanced analysis. So that's the reason I won't put this in the final. Okay. 我讲一次 mediation 跟 moderation 我考试不会考。我介绍原因是因为我的学生在这个班上里面，那我从来会要求学生做复杂的分析。那我知道有的老师会要求学生